Hi, my name is Armandeep Singh, and this is my Lab 3 demo for ECE498 IoT and Cognitive Computing. In this lab, we developed a simple IoT system which uses an edge device, the Raspberry Pi, to capture an image, and this image is sent to the RAI servers here at UIUC, and an accelerated neural net is run using the input image, and it determines essentially which student in the class the input picture is a photo of, and outputs the net ID of the student who the image represents. First thing we'll do is go ahead and take a look at our Node-RED flow. This IoT system was developed using Node-RED, and as you can see here, it begins with an inject node, which basically triggers the flow when it's pressed. And then the next node is a execute node, which runs a Python script on the Raspberry Pi. This script will take an image using the Pi camera. It will then use MTCNN to identify a face within the image and crop the image to just that face. And then this cropped image is stored as a JPEG, and then in the next node is used as an input file into our subflow here, remote FaceNet. And this subflow will take the input image, prepare it for an HTTP post request, which is sent in this node here to the RAI servers, where the GPUs and processing power will be used to run an accelerated neural net to determine the identity of the face. When it is successfully deployed, we'll be given a task ID, and then we use this task ID to continually query the RAI servers until we are given an output URL. And then this querying is done on 1 second intervals using an HTTP GET request node. And then when we finally do receive a URL, that URL is actually a download link, so we download the output using another HTTP request node and store it as a tar.gz file. Following that, we have a couple simple execute nodes which will untar the output and copy the out.txt to the home directory of the Raspberry Pi. And when this subflow concludes, the overall flow has more or less concluded as well. We'll simply be waiting for an end of process debug notification. So I think it's time to go ahead and demonstrate it live. I'm going to start by holding the Pi camera towards my face and then hitting the inject node. And the first output we should be anticipating is a task ID here in the debug column. So as you can see here, the PID is generated, meaning we are running our Python script. And now we have received our task ID, which means we're now in the state of constantly querying the server. So while this is happening, we can go ahead and take a look at the output from the Raspberry Pi. As you can see here, we have a couple new images that we didn't have before, image1.jpg and cropped face image1. So image1.jpg is the original image. As you can see, we have a picture of myself, and then the cropped face image is the cropped photo of me, and then this is what was sent into the servers for the neural net. And as you saw just now, we got our output files generated. Going back to the flow, you can see here we received our complete notification from this debug node here. So now that we hit the out.txt, we can go ahead and take a look at it. Essentially, this file contains the proximity of the input photo compared to every student in this class based on net ID. So my net ID is AS46, and as you can see, I have a distance of 0.65 roughly from the image, which is much smaller than the distances of all the other students. And if we scroll all the way down, we can see that it's identified me as AS46, which is of course correct. So we had a successful run here, and overall we were essentially able to develop a faster version of our Lab 2, where we can use the extremely high computing powers of the RAI servers in place of running everything locally on the edge device, on the Raspberry Pi. And we're able to get an output and identification much faster than we were able to running everything locally. Overall, this lab was a success. Thank you for watching.